Hello, my name is Danny Nowlan and I'm the Director of ChassisSim Technologies. Welcome to this latest ChassisSim video tutorial, and today I'm going to talk to you about a really exciting feature we've just put into ChassisSim version 3.26. A number of you will be aware that ChassisSim has a track replay option. That is, you can take your monster file, and what you can do is you can use this to run track replays. And this has been used across a multitude of different formula and has been used to really good effect. And it's been a great tool to dial in things such as your kinematics if you're unsure of them, and in particular how to just finesse the aero map if it needs finessing. So what we did at ChassisSim was we actually took this concept a little bit further, and what we did was we've added a feature into the Aero modeling, which you'll see here. You've now got a tab that says click here to generate Aero map from Aero map results. So what you do to use this is that you load in your curvature, bump profile, and altitude road camber. And what this is going to do is this is going to use the the open loop simulation feature to actually go through and deduce what the aero maps are. If anything, where this sort of fits in the pecking order is this is sort of the halfway house between the one-touch aero modeling and using the full aero toolbox and using multitude results of the full aero toolbox to generate an aero map. This sort of fits in halfway between it. So let me go through and walk you through an example of how to generate this. So what we'll do is what I've done is I've loaded in a car file, and I've loaded in a circuit file, and I've loaded in my curvature, bump profile, and altitude road camber file. Just for everyone's reference, what I actually did that using the load workspace function. This is actually a really handy little feature that will actually store your car file, all your environment variables, so you're good to go. So what we're going to do here is I'll go to simulate aero modeling, and I'll go to here, click here to generate aero map from track replay results. So I'll import my monster file. Now, one thing that's really key here, ladies and gentlemen, make sure that your steer sign and your lateral AY sign is correct, because we're really going to need that to use this properly. So I'm going to click here to generate, on this tab, to generate the aero map using track replay data. What I'll do is I'll choose a CLA file that's going to go to, and I'm going to choose an aero balance file. Now, the way this currently works is that what it does is it just does it for downforce and aero balance only. This is sort of like, think of this as sort of like opening the batting on this particular feature. So this is definitely going to see a lot more development, but I've put it in this release because with the testing that we've done, this showed considerable promise. So I'm really sort of putting it out there in the ChassisSim community right now for you guys to have a go with it. So we go through, fill in the parameters, click here to determine aero map using the track replay data. So I'm going to click on OK. And what I'll do here is I'll click on 1 to generate the aero map, as we always do. And I am going to click on OK. And now what it's going to do is it's going to go through and do its thing. And you'll see here that the aero analysis results is done. Now, what it's done here is, let me show you what it's done. You'll see here that there have been, if I go to date modified here, we've got 3 files that have been generated. The CLA aero map, and what this has done is this has generated the front right height vector and the rear right height vector, and you'll see that this is pretty much a second order surface fit of the actual raw data. That's for aero balance. Sorry, that's for downforce. And for aero balance is done exactly exactly the same thing. You'll note, because of the fact, even though the results are a better spread than what you would do than using just a single thin sliver of aero map to do a second order surface fit, there are going to be a few anomalies, but again, that's due to the fact that we're just taking one track of aero data. However, the real payoff here comes in this little critter here, which is the which is a file called CLA_aeroband smart data logging model.dat. I'll just open that up. You'll see here for the time being, I've just set the CLAs here and CDAs here to 1, and here that's front right height, rear right height, That's downforce and that's our downforce and our that's our downforce and our aero balance. So, however, there's a bit more you can do with this, and we're about to show you this right now. So what I'm going to do here is I'm going to go back into Simulate Aero Modeling. You'll see here I've got a little tab here called Click here to optimize aeromaps. So I'm just going to click here to optimize the aeromap. And what I'm going to do is I'm going to import that raw file that we've just generated. I'm going to click here to populate aero bounds from aero result. And what I'm going to do is I'm going to click here to optimize aeromap and click here to optimize aero balance. Click here to optimize the aero surface. So what we're going to do here is we're going to use the aero surface optimization to have another crack at what the downforce map and the aero balance map should look like. So we'll click on OK, and I'm going to click on 1 to model the aero coefficients again, and I'll click on OK. And now what this is going to do is this is going to use the aero surface optimization feature to generate that aero map from the files that we've just generated. So we'll let that do its thing for a minute. So if you were doing this in the wild, you would go out and get a cup of coffee and come back to it. Okay, so that's now all done, and so we'll click on cancel. And what we're going to do here is, one of the nice things about the aero surface optimization feature is that it will automatically scale the right height bounds to what's actually in the car file. So what we've got to do to import the results is click on Edit Downforce. We'll click on Import Text File, and so that's just been generated, so we'll import that. Now, you'll notice here that obviously because it's going from incomplete data, you'll see here where it's gotten out of bounds, the results look a little bit funny. Now, there are a couple of ways that you can deal with that. One way that you could deal with that is just simply copy across the right across the results, which I'm just going to do very quickly. So that's just generated our aero bounds. Now, when you do this, the key thing here is to notice what the peak aero value here, which is basically a CLA of 3.02. So I'll click on OK for that. And then I will do the same thing for the Edit Aero Balance Drag Map. And so I'll go to Import Text File. And so that's just been generated. And again, that's basically generated from this data that we've just generated. As you can see, for something that is for something that is basically based off one data set, the results aren't too bad. Sure, this bit in here is probably a little bit funny, but look, you're doing it off one particular aero set, so of one particular data set. So on this one, don't expect miracles. So I'm just going to click on OK, and so to set this up for an aero run, I'm just going to click on here, set the aero balance offset to 0. And set this to 3.02. And what I'm going to do here is there are a couple of ways you can validate it. You can use the open loop sim, or you can use the lap time simulation. It really doesn't matter at this stage of the game. So I just did that a little while before, and this is pretty much the results I got. I just used the track replay simulation, and as you can see, look, it's certainly not perfect. But the power of what we've done is we've gone from one particular data set, and we've come up with something that is pretty representative here. Let me walk you through the channels. So we've got speed and steer, and obviously being the track replay simulation, the speed and the steer are identical. But front pitch, have a look at front pitch and rear pitch. Okay, down the main straight here, it's a little bit off, but you'd expect that being the fact there's a slight crest on that particular bit of the straight. But take a look at here where it's relatively flat. You're actually pretty much in the ball. You're pretty much in the ballpark here. Here, going through this particular section, again, not perfect, but at this stage of the game, from one particular data set, you're never going to get a particularly perfect aero map. However, what you've got with this technique is a really, really good starting point. So one of the things that I would encourage you to do, if you're already a member of the ChassisSim community, give this feature a go. It's when we were doing our initial testing, the thing that really struck me when I was originally doing the original run-ups was how much of a wider section of the aero map that it gave to use. So feel free to go through and do this as part of your analysis to refine your downforce and for your downforce and aero balance map, and throw some mud on the wall. Again, as I've stated, this is work in progress is probably the wrong word for it. This will be a subject of some development, but I really wanted to put it out there in the ChassisSim community now for you guys to really give it a good run and to see what you can do with it. So the next step in this is for you guys to throw some mud on the wall, to try this out for yourself, and to see what a handy tool this can be, and we'll catch you in the next ChassisSim video tutorial.